Bismillahirrahmanirrahim. This is part D of lecture 5 on Descriptive Statistics and Islamic Approach. In the previous part, we explained how current statistics has been built on the wrong foundations. In this lecture, we explained what these are and how we can change them. The goal of this lecture is to explain the foundations of conventional statistics approach, which we could call the approach due to Fisher or Fisherian statistics. Another name for it would be nominalist, to oppose it to what we will propose as the alternative, which is real statistics. We plan to articulate the differences between these two approaches and introduce this name of real statistics to explain that we are working on different foundations from the original discipline as created by Fisher. Another reason for the name real statistics is that it is opposed to imaginary, and Fisherian approach is based on an act of imagination. We imagine that the data comes from an hypothetical infinite population which has no existence in reality. This assumption actually assumes that something is the same, invariant across time, but this something is stochastic. So the nature of this assumption becomes very imprecise and vague and almost impossible to verify. The use that is made of this assumption is to decompose the data into one part which is law and the other part which is the error, and then make imaginary assumptions about the error. This gives us a lot of flexibility because both the law and the error are in our minds. The data does not carry either of these. So this decomposition can be made in many different ways according to our desire. And furthermore, we are free to make any assumption we like about the error regarding its stochastic structure. So this gives us the possibility of proving anything we like, and this is what leads to the most popular book being How to Lie with Statistics, or that there are lies, damned lies in statistics, because in fact using this methodology one can use data to prove anything that you like. To make this more explicit, we can decompose data as the desired law plus error simply by defining the error to be the difference between the two. Now the law that we use is often flexible in the sense that it is specified up to some parameters. There is a large variety of different functional forms, all of which will fit into the same law, the same general description. So because of the flexibility and ambiguity and vagueness about the law that we want to prove, the error also acquires a certain amount of flexibility and becomes unobservable. Once the true error is unobservable, then any assumption that we make about it, about the stochastic structure, becomes almost impossible to verify. And so this methodology allows us to prove any law that we want. The nature of the modeling process is completely misunderstood and completely explained incorrectly in the standard textbooks. Furthermore, the nature of the inference is also misunderstood. Actually, all statistical inference comes from the imaginary assumptions that we make about the error, which are completely unverifiable, but we talk and write as if the inference is coming from the data, and this is what leads to the great power and illusion of statistics. We are saying that here is a conclusion which the data tells us, but actually it's not the data, it's how we have decomposed the data and how we have made imaginary assumptions about the error that leads to these inferences. But the audience is told that this is coming from the data, and the methods are so complex that you cannot understand them, so you better shut up. As opposed to this imaginary Fisherian way of doing statistics, we have an alternative which I will call real statistics, and this says that the data provides us with clues about the underlying realities. The goal of inference is never reduction of the data, as Fisher said, or manipulations of the data. The goal of inference is always outside the data. Now in conventional statistics, the goals are related to data itself. We want to predict the next piece of data. We want to control the data process. But actually, in real statistics, we want to use the data to look at the reality which generates the data. This necessarily involves going beyond the data. And this radically changes the task of the teacher. We cannot look at the data in isolation. We have to look at the data together with the real world process which generates the data. And this leads to a completely different approach to statistics itself. One way to think about Fisherian statistics is to think about it as the goal of finding stochastic patterns in the data. Whether these patterns are valid or whether we are seeing them in the data or whether they are accidental cannot be assessed directly. So the only way to assess this is to look at whether predictions using this pattern hold, whether the pattern that exists in the past data that we have discovered continues to hold for the future data. And this is called prediction, and it's almost central to the Fisherian methodology as almost the only way of verifying whether or not your model is correct. The other tools are fit, how well the pattern fits to the data, and also control, how well can you use this pattern to control future outcomes. These are the basic tools, but none of these are actually important in real statistics. And the failure of this Fisherian methodology is illustrated by a failure of a forecast competition which was run by the International Journal of Forecasting for many years before being abandoned because it didn't yield any information. So what the Journal of Forecasting did was to generate thousands of real world series and ask people to find a method which would forecast them. Now this forecasting, because you look for patterns, you can apply this pattern search to any kind of data at all. But when you think about the reality of it, the forecast will work if the pattern that you see in the data corresponds to the real world mechanism, and this which generates the data. This can sometimes happen by accident, but if you are never looking for it and if you are never testing it, then this will only happen by accident. So basically, when you have a generalized pattern finding formula which works for all data, this can never be the correct approach in a real statistical approach, because the pattern finding is only a first step. We look at a pattern, and to validate the pattern, we must check for correspondence between the pattern and the underlying reality, which always involves going beyond the data, whereas the forecast competition never looked beyond the data itself to the real world structures which generate the data. So it was bound to fail, and that is what actually happened. The different methods have different types of performances on different types of data over different time periods, and there was no consistency, and there was no one method which worked better than any other. So in real statistics, our goal is to look at the behavior of the data, look at it by just graphing it, and by analyzing it in different intuitive, easy to understand ways in order to get clues about the operation of the real world. How does the real world operate if it generates this data? And in particular, we would like to discover causal effects and also unobservable objects which are not part of the things which you can measure. These are things like preferences, what is in the heart of the people, expectations, what is in the minds of the people, what is the forecast. These are not directly observable, but the data provides us with clues to these. And similarly, causal effects are always unobservable. Descriptive statistics, which is what we are studying now, is just looking at the surface appearances to try to get some first idea about the real world. The deeper analyses about causal effects and about unobservable objects which drive will be built upon this basic understanding. So we don't intend to explore these deeper aspects in this course just as yet. In this way, descriptive statistics corresponds closely to what was called EDA, or exploratory data analysis, by Tukey. Tukey also understood that the standard approach involved assuming a model is true and then assessing and utilizing the model, and he called that confirmatory data analysis, which starts by the assumption of a model. And he said that as opposed to this, we start with no assumptions and we explore the data. We just look at the data. So this is fine, a beginning, but the goal of EDA was perhaps different from the goal that we have adopted in real statistics. The goal of EDA was really more to assess whether or not the Fisherian type assumptions were valid for the data. So basically, they were attempts to validate the Fisherian methodology rather than to directly look at the real world on the basis of the data. So this makes the task of a descriptive statistic teacher much more difficult, because we have to actually learn more than just the study of numbers. For example, biometrics is an example of real statistics, because we actually study biological mechanisms in conjunction with the statistics that are generated. And similarly, in economics, we must study real world mechanisms. Like in the last lecture, we studied the quantity theory of money in terms of an economic theory in order to understand how we should look at the numbers for money and prices. This makes teaching difficult because it can only be by apprenticeship. There are no general methods which apply across the board to all types of data. We must look at the real world context, but the real world context changes from data set to data set. So for each data set, we must acquire a different set of skills and understandings about the real world context. This means that we have to look at case studies of statistics, and after studying a lot of different cases about how numbers are used to understand the real world, the student will get a feel for how to do this and will be able to use this. But this requires, there is no mechanical approach to the analysis of numbers, in contrast to the standard approach. And we must develop understanding of the real world. So to conclude this lecture, in this course, we will be trying to learn how to look at the data to understand the real world processes underneath the data. The more complex and deeper aspects of real statistics involve causality, probability, randomization, and these are part of real statistics. But in this course, we will be developing the elementary aspects, and so these deeper concepts will be developed later. The ways of looking at the data were not possible earlier in the century. That is, Sir Ronald Fisher did not have access to the computers which allow you to make the histogram of any number of data and to change the histogram according to bin size with a click, or to make graphs. And so basically his method was developed, and it was a brilliant method, which allowed the reduction of 1,000 points of data to 3, 4, or 5 points, and allowed us to create patterns, mathematical patterns, by just assuming that they held. But now we can, and there was a huge amount of very complicated and impressive mathematical machinery developed to enable this Fisherian approach. Now, rather radically, I'm saying that we can throw all of this out of the window because it's based on pure imaginary assumptions. There must be cases, there are cases in fact, where some of these assumptions actually do hold as a close approximation to reality. So in such cases, we would be able to use the Fisherian methodology when there is genuine randomization and certain conditions we will study. But in the vast majority of cases, this methodology would be of no use. So